Good day, sir. This is the electropneumatic conveyor belt system that I'm about to present. So let's tackle it in detail. Let's take a closer view and let's look at the cylinders in there. So first we have a feeder, which is this one. It has two reed switches, as you can see here. We have a probe cylinder and we have a block pusher here. And then we also have these input transducers, push buttons and sensors. And then next we have an up or down pneumatic cylinder for our planar cartesian manipulator. And then this is the suction, and then this is the back and front. And then for the cylinders that transfer the block to the conveyor, these are cylinder F and these are cylinder G. And then we have a block stopper here, and then there's this pick and place rotary arm that puts a little cylinder on top of the block. So this is cylinder I, this is the gripper, and this is the semi-rotary actuator. And then for the conveyor ejection cylinders, which are right here, this is cylinder L and this is cylinder M. And then lastly, for our block collector, this is the gripper, and then this is our rotary cylinder. This is the pneumatic diagram for the conveyor belt system. So first, we have our user inputs here. We have a selector switch, a reset button, and a start button. This is a capacitance sensor, which is used to detect if there are blocks available in the storage. So let's simulate the program. Once the user clicks the selector button, he or she is now able to switch between manual and auto mode. And then if there are no blocks in the storage, the sequence will not initiate upon the press of start push button. So it has to detect it first. So when we press start, the feeder will now extend, which will be followed by our probe cylinder, B plus, then B minus. And then at the same time, the block pusher is going to extend and the feeder is going to retract. Just like that. Once the block pusher has extended it and moved the block onto the next station, it's now going to be processed by this planar cartesian manipulator, where it's going to put a donut-shaped material on top of it. So like that, it is now reaching for the material to place. So it's grasping it with a suction, and then lifting it, and then putting it in front, and then putting it down and releasing it. And then going up, and once this cylinder went up, the block is now pushed towards the conveyor, just like that. And then once it is now at the conveyor, the motor is gonna rotate clockwise. Since the motor is rotating clockwise, the block is eventually gonna trigger this inductive sensor. When this inductive sensor is triggered, the block will be stopped. And then another pick and place manipulator will put a cylindrical shaped object on top of it. So cylinder I is now reaching for the cylindrical material, and then it's now gripping it, and then it's gonna lift it, and then the rotary actuator is gonna put it at the front, then it's gonna go down and then release it, then it's gonna go up again. Now once the material has been placed, 5 seconds is allotted for our optical sensor to sense it. So if we continue, let's actually first see what happens if the material is non-existent. So this is a fail-safe. The material is gonna go to the reject chute. So as you can see, our block stopper is now retracted, and our motor is still continues rotating clockwise. That means that the object is gonna get eventually pushed onto our reject chute for 7 seconds. Once that is done, everything resets. We can now start a new cycle, which is A plus, B plus, C plus, D plus S plus D minus E plus D plus S minus D minus. And then it's gonna go to the conveyor again. It's gonna trigger this inductive sensor. It's gonna stop and a cylinder will be put on top of it. And then what if it was successful? So here it will this will remove the cylinder that has been placed, just like that. And now, as you can see, the motor is now spinning counterclockwise. That means that it is going back. Since it is going back, it's also going to trigger this sensor here. So once that is triggered, the ejector cylinder will push it onto the station towards the planar Cartesian manipulator. So here, it is now gonna remove the donut-shaped material. And then it's gonna be pushed onto the conveyor again. Now, there's another if here. If the section for our successful outputs are filled, then the material will still go to the reject chute. Otherwise, it will be picked up and put on its proper place. So let's simulate that. Oh, I forgot. Now, since the motor is spinning clockwise, it is gonna eventually trigger this optical sensor here. And once that optical sensor is triggered, this is what happens. It is gonna get picked by our last pick and place manipulator. Just like that. And then the program resets. Nothing is energized. Now let's see what would happen if we pressed emergency stop midway. So let's start. Emergency stop. As you can see, nothing is energized. And if we unpress it, and then you will see that cylinder A has been already extended. How do we retract it? We just press reset for 3 seconds, and that would be it. We also have an auto mode, at which once the resulting material has been classified as a reject or successful, it's gonna trigger another sequence. It's gonna go to the conveyor. It's gonna trigger this. Cylinder is gonna get put through it. Now, observe what would happen. If this is a reject, once the program has classified it as reject, multiple things are gonna happen at once. The program is gonna process a new block, and at the same time, it is putting the reject material onto our reject chute. And then it will now be finished soon, this one. And the sequence is uninterrupted, just like that. So that's pretty much it for the features of this conveyor belt system. I've separated the circuit diagram into different groups so that it is easier to debug, and I've separated our signal input and our signal output elements. That's it. Thank you for watching.